Hi, today I will show you how to solve for a rational inequality. A definition of a rational inequality is the kind of problem you have it here. You have the inequality sign in the problem, and you also have variable at the denominator. That is the key word, variable at the denominator. So the whole thing is called rational inequality. To solve for a rational inequality, you have to solve it as a rational equation. So first step, we solve it as equation. So step number 1, solve as an equation. So we have 1 over x plus 1 over x plus 9 equals 1 over 6. Now this is the rational equation. As I show you how to solve for this from the previous clip, we have to define the LCD. The LCD in this case would be all the factors of the denominators put together. So in this case we have 6, we have x plus 9. And after we identified the LCD, least common denominator, we have to define the domain of the equation. The domain of the equation is a set of all real numbers except for those numbers that make the denominator 0. In this case we have 0. That would make this denominator 0. And 1 divided by 0, undefined. So 0 is not included in the domain. And the next one, the second fraction, if you replace x by negative 9, and you see it negative 9 plus 9 would be 0. So therefore, negative 9 would make this denominator 0. And 1 over 0, undefined again. So negative 9 is no good. Not in the domain. Except for this. I have 1 over 6, no variable. So you don't have to worry about it. So this is good. Okay? So the domain of this rational equation would be all real numbers except for 0 or negative 9. Why we have to define the domain? Because after solving for x, the solution happened to be either 0 or negative 9. Then we have to identify it as extraneous. Extraneous solution is the kind of solution would make the denominator 0. Make the whole thing undefined. So watch out for those. And the next step, solving. We go back to the equation. I multiply everything by the LCD. 6x, x plus 9. 6x, x plus 9. And we multiply to the left with this, and you have to multiply to the right with the LCD as well, because we want to preserve the equality of the equation. Now, if you look at this, these two divide out. So you're left with 6 times x plus 9. The second term, these two divide out. So you left with 6x. And over here, 6 and 6 divide out. So you're left with x times x plus 9. Then solve for this equation. Nice. No more denominator left. We solve. We distribute the 6 in. So I have 6x plus 54. 6 times 9 plus 6x equals x squared plus 9x. And on the left, combine like terms, 6x plus 6x, 12x, plus 54. And this we have x squared plus 9x. Now, this is called nonlinear equation. In order for us to solve a nonlinear equation, make sure we take all terms to one side of the equation and rearrange all terms in descending order of the exponents. So the highest power comes first, then the next one, and the next one, and set it equal to 0. Notice we have the power of 2. That is the leading terms. You want to preserve the sign of this term as positive. So therefore, I would like to solve for this by taking all the terms to the right side of the equation. So I minus 12x. I minus 12x to 9x, I have negative 3x. I subtract 54. I subtract 54, so I have negative 54. And nothing left here, 0. Repeat again one more time. How did I go from here to here? I minus 12x here, 0. Minus 12x here, I have negative 3x. I subtract 54 to the left and subtract 54 to the right. I have this. And solving for this. X squared minus 3x minus 54 could be factored. So I have x squared, x times x, 54 and negative 3x. The two numbers multiply together to give me negative 54. And when you combine them together, you have negative 3 would be negative 9 plus 6. This is the factoring form of this trinomial. And we use zero factor property to solve. So I set x minus 9 equals 0 or x plus 6 equals 0. And one solution is negative 6. Subtract 6 to both sides and add 9 to both sides. And one solution is 9. And these two solutions are good, passing this test. None of them is 0 or negative 9. So they are good. So after we solve for the equation, and we ask ourselves, how could I solve for the inequality? We line up the solution on the number line. And remember, before we do that, we have to remove the two numbers that make the denominator 0, as we declared earlier. And those are negative 9 and 0. So I assume that 0 is somewhere here. We remove it. And negative 9 would be somewhere here. I removed it. And then I line up negative 6 and 9 on my number line. So negative 6 somewhere here. And 9 is somewhere here. So we have these numbers on the number line. It will divide the number line into intervals from negative infinity to negative 9, from negative 9 to negative 6, and from negative 6 to 0, 0 to 9, and 9 to infinity. But please remember, these are no longer there. There are holes around them. That means the number had been removed. And also remember, when you want to enclose negative 6 and 9 in the solution, you go back to the inequality. If we see the equal sign with the inequality, then negative 6 and 9 will be part of the solution, the shading of the solution. Now, we have 1, 2, 3, 4, 5 intervals. So which one would be good? You only pick the one contain the numbers. And those numbers will pass the inequality test when you substitute those numbers in here for x. So I should assume that we want to test one interval first. So I would like to test x equals 1. The reason I pick x equals 1 because nice number. It's small enough for me to do the mental math. So I test this interval because 1 is somewhere here. So we'll go back to the beginning. So we substitute x by 1. So here I have 1 over 1 plus 1 over x now is 1. 1 plus 9. Okay, we compare to see if the left side is greater than or equal to 1/6. Now notice, 1 over 1 is 1. 1 plus 1 over 10 is surely greater than 1 over 6. Because 1 is already bigger than 1/6. So this is a good interval. It's passing the inequality test. So this is yes. And then we continue on if you want to. If you want to test this interval, you pick 10, 11, or so. If you want to test this interval, you can pick -1, -2, or so, and so on. But fortunately, you don't have to do all of these intervals because it takes on the alternating personality. If this interval is yes, the next one would fail. No good. If this is yes, this one would fail. No good. And if this fails, this would pass. Yes. And no. And you see it alternating. No, yes, no, yes, no. So these yes intervals are good. We will enclose it. So we put the bracket here, parenthesis here. The reason I put parentheses because -9 is not there. 0 is not there. Okay? And I enclose this with the bracket because these are the solution. And we have the equal sign here. And the final answer would be, write down, x belong to all the numbers start right after -9 up to -6, including -6, or all the numbers start right after 0 up to 9, including 9. So these are the two good intervals. So please remember, the alternating yes, no only works when the solution you earn at the end would not be these exchanges. If any of these solutions happen to be one of these numbers, then the pattern would not follow as it is, like this. In that case, you have to test all intervals. And I would like to summarize step by step how to solve for a rational inequality again. First, we solve it as an equation. In doing so, we have to define the LCD. And we go back to the equation. We multiply every single term by the LCD so we can clear all the denominators out. And we solve for the unknown. Watch out for the exchanges. Exchanges is the number that make the denominator 0. And after you solve for these solutions, now remember, these are all good solutions, and line them up. And do not forget to remove the exchanges on the number line. And we pick a number to test. The number happened to be within the interval you want to test. And you substitute that number into the beginning, the inequality, as I did. I picked 1. I work it out. If it is passing the test, we label yes. And we alternate no, no. The next one is yes. And we only pick out the yes interval as part of the solution.